Hello dear student, how are you? Welcome to my channel. I hope you are all will be fine. I'm also fine, thank you. So let's start today topic. Today topic is about carbines. What is carbine? And today lecture we will study about definition of carbine, structure of carbine, stability of carbine, reactivity of carbine, formation of carbine, reaction of carbine, and rearrangements of carbine. So these all will be studied in today lecture. Okay, let's start today topic. Are you ready? Okay. So let's start. Let's define carbene. What is carbene? Carbenes are the species. Carbene are neutral species. Carbene are neutral species, divalent, highly reactive carbon intermediate containing two single bond and two non-bonding electrons around a carbon. This is called carbenes. Carbenes are neutrals, divalent, highly reactive, highly reactive carbon intermediate, carbon intermediate containing two single bonds and two pi bonding, two non-bonding electrons, two non-bonding electrons around a carbon like XCY double bond. This is carbene. Carbene are neutral divalent high reactive carbon intermediate containing two single bond and two non-bonding electron around a carbon is called carbene. This is, let's suppose this is carbon which is attached with X atom and also attached with Y groups. If this carbon have one lone pair and one empty orbital, this is empty orbital or vacant orbital, while this contain two electron, this orbital contain two electron, so that species is called carbene. This carbon will be called carbene. Is it clear? Carbene are those species, carbene are those carbon, carbenes are neutral divalent highly reactive carbon, highly reactive because it also acts as a nucleophile as well as also acts as a electrophile. A high reactive carbon intermediate containing two single bond like that and two non-bonding electron around a carbon is called carbene. That is called carbene. Is it clear? And the simplest carbene is methylene group. Methylene is the simplest carbene. That is CH2. The structure is a CH here two electron lone pair, here is vacant orbital. This is called carbene. This is the simplest carbene called methylene. Other carbenes are simply named as substituted derivatives of methylene, like it may can be phenyl CH carbene, may can be ClCCl carbene, maybe RCR carbene. These all are derivatives of carbenes. These all are derivatives of methylene carbene. Is that clear? This is carbene. This is how you can define this carbene. So let's start. Let's explain the structure of carbene. Structure of carbene. Carbene, as this is like, this is carbon, this is one bonded that are bonded with alkyl group, this is another bonded with another alkyl group, or you can say that is R prime, that is R. So this is, let's suppose this is one orbital of one p orbital of the carbon, and this is another p orbital that have free lone pair, that have one lone pair, free electron pair. These electron pair, let's suppose this is one electron pair, this is one bond pair, this is one bond pair. So this structure, the hybridization of carbene will be hybridization of carbene will be hybridization of carbene will be sp2 hybridization, because one lone pair, two bond pair, two sigma bond pair, so it will be sp2 hybridization. Total 3 electron pair, so it will be sp2 hybridization. So this orbital will be sp2 sp2 orbital. These bonded are sp2 bonded, while this vacant orbital is called vacant p orbital. This is called vacant p orbital. These are the structure of carbenes. While while carbene have two types, that have two types. It is on the basis of the free lone pair, that how the electron pair are present in the carbene. One uh, the one pair is called, the one type of carbene is called singlet carbine. Singlet carbine, that is singlet carbine. While the another type is called triplet carbine. What this mean? What will be the singlet carbene and what will be the triplet carbene? The singlet carbene will be called when the structure is like that, when the electron pair is present, when the two electron is present in one orbital and some lone pair, it will be called, this structure will be called, this carbene will be called singlet carbene. While triplet carbene will be called, triplet carbene will be like that, this is one bond with carbon, this is another bond with carbon, alkyl group 2, alkyl group 30. This is one orbital, vacant orbital, this is another orbital. If one electron is present here in this orbital and one electron is present in this orbital, this structure, this carbene will be called triplet carbene. These are two types, this will be called singlet carbene and this will be called triplet carbene. Or you can say that triplet carbene and triplet carbene, the two electron bonding, the two non-bonding electrons have parallel spin. If they have parallel spin, the m which is called electron spin, the spin multiplicity, it will be equal to 1. It will be equal to 1 because m is equal to, because let's take the correct position of camera, where m is equal to 2s plus 1. Here is the spin is 2. If there is 2 spin, there is a 1. So if all the electrons have anti-parallel spin, s will be equal to 0. So m will be equal to 1. M will be equal to 1. That means that here in this case in singlet carbene, m is equal to 1. When m is equal to 1, when m is equal to 1, it will be lower spin. While in case of triplet carbene, m will be equal to, where s is equal to 1, so 2s 1 plus 1, it will be equal to 3. So m will be 3. So here is a higher m, so it will be called triplet carbene and it will be called singlet carbene. That's why these are named. So let's discuss the stability of carbenes. Before stability, I am just showing another thing, that the triplet carbene is an ESR, electron spin resonance, and electron spin resonance spectroscopy. The triplet carbene will be like a diradical. It means it will be like here two radical are present, so it is one electron and it is one electron in each orbital, so it will be called diradical. So in ESR it will be like diradical in ESR, in electron spin resonance. So the triplet carbene. Is it clear? Okay, let's start the stability of carbene. Also, the the bond between the two carbon, the bond between these two things, like in water, there is H there is 104.5 degree angle in between these two bonded. Here is two lone pair. So but in case of here is the angle will be between, in both cases angle will be in between 100 to 150 degree. It will be the angle will be in between these two, are in between these two bonded, the angle will be between 100 to 150. Is it clear? Okay, let's start stability of carbenes. So let's start stability of carbene. What is meant by stability of carbene? There is two types of carbene. One is triplet carbene and one is singlet carbene. One is singlet carbene. Singlet carbene have the structure like that. That is R, one bar, one lone pair, one lone pair. It will be called singlet carbene, while this carbene will be called triplet carbene. Which one carbene will be, this is one electron in this orbital, one electron in this orbital, this is called triplet carbene. So which carbene will be more stable? Carbene, triplet carbene will be more stable than singlet carbene. Why? Because here is two electron present in one orbital. Since electronic repulsion will be produced, since electron, because both have two negative charges, so electronic, but in case of triplet carbene, the electronic repulsion will be minimum as compared to the in singlet case. So that's why this will be more stable, and the stabilizing energy for triplet is 7.7 kilocalorie per mole. It is more stable. Triplet carbene is 7.7 to 10 kilocalorie per mole stable than the singlet carbenes. The triplet carbene are 7.7 to 10 kilocalorie per mole stable than singlet carbene. The triplet carbene is stable than singlet carbene. Is it right? That is between triplet and singlet stability. But when singlet carbene, the alkyl group, instead of alkyl group, when there is a electron donating group attached, or a pi electron donor group attached, group pi electron, when there is pi electron donor group attached instead of alkyl group, after that this will say the singlet carbene will be more stable than triplet. What is the reason behind this? The reason behind this, because here is also one vacant orbital present in singlet carbene. If one electron singlet carbene is present, then it will be like that. Let's take correct position of the board. So then what will be like that? It will be like that. Let's suppose this is one x. X is for halogen group. This is xc, one vacant orbital, and this is one another orbital. This is x. Let's suppose this have electron. So this x has also electron. It can also make a pi bond here. It will be like that. X, it will become positive charge, it will become negative charge, lone pair is remain, it is x. So it will be resonating stabilized, that will be shift here, so it will be like that. C double bond x plus minus lone pair. So the resonance will be stabilized it, because it has all one lone pair. So this structure will be the singlet carbene in case of when there is two bonded of carbene, when the carbenes are bonded with the two a pi electron donor group, so that it will be more stable than triplet carbenes. Is that clear? But in case of in case of halogen groups, which halogen group will give more stability to the carbenes? Mean in case of singlet carbenes, like when instead of X there is attached fluorine, chlorine, bromine, iodine, which one will be give more stability to the carbene? In case of this halogen group, the fluorine will be give more stability to the carbene. Why? Fluorine will be give more stability to the chlorine, to the carbene, while more fluorine will be more stable, give more stability to the carbene as compared to chlorine, which will give more stability to the carbene as compared to bromine, and so on, up to iodine. Why? Because here is fluorine. Fluorine has also p orbital, because it is in same period, like carbon. The carbon is also in third period, while the carbon is also in second period, while fluorine is also in second period. So in carbon there is the vacant p orbital is 2p, while in case of fluorine there is also the pi, that the orbital that contain pi electron, that is also 2p. So that's why overlapping will be maximum, and maximum stable bond will be produced. But in case of chlorine, the size of p orbital is greater than the 2p, the orbital of the vacant orbital of carbon, that is 2p. So that's why the overlapping will be not as much better like as fluorine. So that's why fluorine will be give more stability to the singlet carbene, while as compared to chlorine will be give more stability to the carbene as compared to bromine, and so on. That will be the stability order of the carbenes. I hope you will be clear. Any question, any confusion? Also you can ask me in comment section. Okay, thank you. Or you can ask me in my personal WhatsApp, that my personal WhatsApp, I put it in I drop it in my personal WhatsApp number in description box. Okay, thank you. Let's proceed the topic to formation of carbenes, reactivity of carbene. So reactivity of carbene means that when the case of iodine, when there is iodine attached, iodine will show more reactivity because it will have less stability to the carbene. So in case of halogen groups, when they are attached with carbene, the electronegativity, the stability, the reactivity will be increases, will be decreases from top to bottom. The stability, the reactivity will be decreases from top to bottom, where stability will be uh, stability will be decreases from top to bottom, while reactivity will be increases. Reactivity will be increases from top to bottom, while stability will be decreases from top to bottom. Is that clear? Okay, thank you. Let's start. Let's proceed the topic. Formation of carbene. Carbenes are usually generated from the precursor of loss of small or stable molecule, small and stable molecule. When there is when there is loss, a stable molecule occur, small and stable molecule occur, the carbene will be generated. Like that, for example, when there is diazo compound, how carbene are generated from diazo compound, like that. What is diazo compound? Diazo compound is that is R R C double bond N. This is diazo compound N2. When heat, when sunlight, when UV radiation, when sunlight or heat given to the system, heat absorbed by system, it will be changed into carbene. It will be changed into carbene plus N2, while N2 is a stable molecule. So small and stable molecule are lost and carbene are generated. Thus carbene can be generated. Carbene can be generated from the loss of stable molecule, from the loss of small and stable molecule, like from diazo compound. That is one reaction. Also it can be generated from ketone group, from ketenes, from ketenes. How is ketene? That is ketene. Let's take the correct position of the camera. Okay, that is ketene. R C double bond C double bond O. This is ketene. When the system are heated, or in the presence of HV UV radiation, in the presence of high radiation, it will be changed and to it will be generate carbene plus carbon monoxide. Well, carbon monoxide is also a single, is also a stable molecule, carbon monoxide. So carbene can be generated like this. Carbene can be formed from this. These are the formations of carbenes. Is it clear? Also can be generated from alide. Also can be generated from alide. YLIDS, alide. Alide like this: R C R C S CH3 CH3, while S has positive charge and C has negative charge. Positive charge and negative charge. When this heat are given to the system, when heat are absorbed by the system, it will change into carbene. Plus the bond will be break here, so it will be changed into carbene plus S CH3 to CH3. It is also stable molecule. SCH3 CH3 SCH3, it is also a stable molecule. So carbene can be generated from halides, also from ketenes, also from diazo compound. There are so many different things that carbene can be generated from them. So I think the formation, reactivity, stability, structure and definition will be cleared of carbenes. I hope it will be cleared. Okay, thank you. Let's start reaction of carbene. So let's take first the reaction of singlet carbine. Singlet carbine that contain lone pair, that contain two electron pair in single orbital. So it is called singlet carbine. So a singlet carbine, the reaction of carbenes, or you can say that cyclo addition to alkenes, a reaction of cyclo addition to alkenes, cycloaddition to alkene. How is that? When there is singlet carbene, that is attack on carbene. When there is alkene that attack on carbene, this is H. It will be like that. That is CH2 when the lone pair is hit. Here is also one vacant orbital present. So the lone pair will be like the double bond, the pi bond will be attack on the vacant orbital. The carbene will be act as a electrophile, while at the same time carbene will also be act as a nucleophile. The positive charge that come on the one carbene, they will be attack on the carbon. So it will be formed CR. It will be like that. That is CH2 CH2 H H. This structure will be formed. This structure is called cis cyclopropane. Cis cyclopropane. Is that clear? Okay. But the reaction of triplet alkene will be triplet carbene will be like that. If there is triplet alkene, no, sorry, triplet carbene, it will be like that. That is R. That is to cycloaddition of alkene, R C double bond C R H H. This is carbene CH2. This is lone pair of electrons in two different orbital of carbene. So this bond will be partially attack, means one electron will be attack on this one and one electron will be remain here. So it will be like that. When they are attacked, it will be formed this C C R H R. One electron will be remain here, that is H. This is CH2. One electron will also remain here because one orbital is bonded with this carbon and one orbital remains, so one electron is present in the system. So after that, the rotation will be occur. Rotation of carbon carbon bond will be occur. Rotation of carbon carbon bond will be occur. Rotation of CC bond, because the trans position is more stable than the cis position, so the R will become downward while H will become upward. So the structure will be formed. R C single bond C H R, the electron will be in same position. H C H2, the electron will be in same position. Is it clear? The structure will be formed. After that, inversion of spin will be occur. Spin inversion will be occur. Spin inversion. Spin inversion. Spin inversion will be occur. Spin inversion means the electron will be like that. That is R C C H R H C H2 CH2. The electron will be like that, but here the electron will be before uh, before the electron in a down position, but now spin rotation will be occur, so the spin will be like that. After that, when the spin is opposite, it can also be bonded, so it will be make bond. It will be like that. A ring closure will be occur. A ring closure will be occur. A ring closure will be like that. R C C H R H C H2 double single one. It will be ring formed, and this ring is also called transcyclopropane. This is called transcyclopropane. Is it clear? This will be cis transcyclopropane. If when the rotation of the CC bond is not occur, after that when there is directly spin inversion occur, after that the cis cyclopropane will be formed. After that the cis cyclopropane will be formed, not a transcyclopropane will be formed. The rotation of CC bond will produce the trans position will be stable position, so the trans is more stable than the cis position. I hope you will be clear. These are the reactivity of alkene, reactivity of carbene. That means that carbenes are show some reactivity to the to some electrophile as well as to up to nucleophile, because carbene has also a vacant orbital and it also has the electro. It can also act as an electrophile, also act as a nucleophile, also act as a free radical. Because in triplet case it is also called diradical, because it is like diradical. It because two orbital contain one electron pair, so that will be act as a radical diradical. But in case of singlet carbine, it will act as a nucleophile, because one lone pair is present on carbon, while in also one vacant orbital is present, which can act as a electrophile. So electrophile and nucleophile will so carbene can also act as a nucleophile, as well as also act as an electrophile, also act as a free radical. Is that clear? I think there will be no confusion. So let's start. How rearrangement of carbene occur? Rearrangement of carbene. Rearrangement of carbene. What do you mean? What it mean by rearrangement of carbene? Let's start. So rearrangement of carbene. How rearrangement of carbene occur? When there is alkyl carbene. When there is alkyl carbene can undergo rearrangement with migration of hydrogen or alkyl group. How the migration of hydrogen and alkyl group occur? And let's suppose this is one alkyl carbene. That is one alkyl carbene. That is a CH3, CH2, CH. Here is also H. Here is also H plus CH2. This is carbene. Yeah, right. Not CH2, sorry, CH. This is carbene, because one orbital will be vacant like that. So when this carbene, this bond will be shift here, this bond will be shift, the lone pair will, let's suppose the lone pair is down the carbon, so this lone pair will be shift to this carbon, make double bond, while this hydrogen will be shift to this carbon and make a stable compound CH3 CH2 CH double bond CH2. It is more stable than the carbene state when this compound is in carbene state. So it will be more stable because it is reactive, because it is also one electron pair, also weakened orbital, also can act as a nucleophile, also can act as an electrophile. So that's why that will be show some reactivity, but that is a stable compound as compared to the carbenes, because here is only electrophilic addition reaction can occur, but here is also nucleophilic addition can be occur, electrophilic addition can be occur. So its reactivity will be more. That's why they can be rearrangement of hydrogen will be transformed, hydrogen will be migrate from one carbon to another carbon to make a stable compound in case of carbene. That will be rearrangement of carbene occur. Also it can also take place in case of alkyl carbene when there is alkyl migration can also take place like that. That is CH. This is lone pair and lone pair of carbene when it is in singlet state. So it will be shift here, make double bond, and the alkyl group will be shift here. So it will be produced, it will generate RCR. It will be like that, RCR double bond CHR. It will be like that. It is a more stable. Is it clear? So these are the about of these are the about of definition, structure, stability, reactivity, formation and reaction and rearrangement of carbenes. I hope you all will be clear. If you have any confusion, any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp from me. In my personal WhatsApp, I put my personal WhatsApp number in the description box, as well as I put my Gmail address in the description box. You can get my Gmail and my personal WhatsApp from the description box if you have any confusion. Okay, thank you. Please subscribe my channel if you are if you like my teaching style, if you like my procedure, please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you. Best of luck, my dear student. Best of luck, very best of luck.